Hello everyone, how are you all? Today we start with this question. In this question, the question asks about major product in the following reaction sequence. In this series, we are solving IIT JAM previous year questions, and this is day 13. We are going to solve this question. In this question, they give benzaldehyde, and here they give three steps or three sequence. We have to follow these sequence. In first step, they give potassium cyanide in the presence of ethanol, and in second step they give dilute HNO3, and in third step what they give aqueous KOH. In this reaction, two name reaction are involved. First is benzoin condensation. Two benzaldehyde molecule react with KCN in the presence of ethanol, and what we get benzoin as our product. And second step, they give dilute HNO3, and dilute HNO3 oxidize this hydroxyl group and convert this hydroxyl group into carbonyl group. So in third step, second name reaction involved. This is benzyl benzylic acid rearrangement, and in this rearrangement 1,2-dicarbonyl group convert into benzylic acid or alpha hydroxy acid, and this conversion happen in basic medium. So let's get start. First we draw this molecule like this. Because they both benzaldehyde attach with one sigma bond, so this sigma bond will rotate easily. So this aldehyde group comes here when we rotate this ring 180 degree. If we rotate this ring 180 degree, this aldehyde group comes here, and they both aldehyde group comes in one plane. So we can proceed our first step easily. So here what we get, we rotate this ring. Here we have one aldehyde group. Here also we have one aldehyde group. So this is in first step, they give KCN in the presence of ethanol. So react with KCN. In KCN, this cyanide group act as nucleophile at this carbonyl group. This cyanide group attack this aldehyde group or that aldehyde group. Here no difference, because they not give any substituent attached with ring. So this nucleophile attack any of these aldehyde, any one. So this cyanide attack here or here, it is same. So this cyanide group, so we assume this cyanide group attack on this carbonyl group. So after this nucleophilic attack, what we get? After this nucleophilic attack, we get, so after so this nucleophile attack here, and this carbon oxygen bond and this carbon oxygen bond electron shift on oxygen atom. So here what we get, O negative. Here one hydrogen is present, and this is our nucleophile cyanide attached here. And here what we have? We have here aldehyde group. So what happen in next step? We have ethanol also in this step. So what ethanol work here? These electron attract this hydrogen and bond with this, and in this step ethoxide ion will remove, and here cyanide, here OH, and here what we have? One hydrogen, and we have one aldehyde group here. So we draw aldehyde group like this, and in next step what happen? This ethoxide ion, this ethoxide, in what happen in next step? This oxygen electron attract this hydrogen and bond with this, and this hydrogen and this carbon hydrogen electron shift on this carbon. So here oxygen electron attract this hydrogen and bond with this, and this carbon hydrogen bond electron shift to this carbon atom. So what do we get? We get on carbon atom we get negative charge. Here one OH is present and one cyanide is present, and here our carbonyl group is present. So this electron attack this carbonyl group, and carbon carbon bond is formed, and this carbon oxygen bond electron shift to this oxygen atom. So here this carbon atom bond with this carbon atom, and this carbon atom have O negative, one hydrogen atom, and attach with here, and this carbon atom attach with one hydroxyl group and one cyanide group. So what we get? We get 1, 2, 3, 4, 5. So here we get 6-member ring as intermediate. After this step, so here what we get? We get 6-member ring intermediate is formed between these two phenyl rings. So in next step what happen? This oxygen atom electron attract this hydrogen, and this hydrogen leave this oxygen and bond with this oxygen, and here negative charge generate because oxygen hydrogen bond electron shift to this oxygen atom. So here what we get, we draw our 6-member ring like this. Here our 6-member ring. This 6-member ring we can draw like this, and C1 carbon what we have, cyanide group, and here this hydrogen, this hydride shift to this oxygen atom. So here what we have, O negative, and this carbon atom OH, and this carbon atom attached with OH. We number this also, 1 2 3 4 5 6. So after this step what we get, we get this structure like this. This electron, this oxygen electron return to this carbon oxygen bond, and this cyanide group leave this group, and this cyanide leave this carbon atom, leave as leaving group. And in next step what we get this structure. On C1 carbon we have carbonyl group, C6 carbon, and carbon number 6 we have one hydroxyl group. So this is our product after step 1. So after this step we get this product, and we call this benzoin. What we call? We call this structure benzoin. Here see, benzoin condensation, benzaldehyde. Here intermolecular benzaldehyde, and here intermolecular aldehyde participate in this reaction, and at the end we get benzoin as a product. What we get? Benzoin as product. In benzoin, and this is benzoin structure, one carbonyl group and one hydroxyl group attached with nearest carbon. So here we get same, one carbonyl group and adjacent carbon, carbonyl group and adjacent carbon, one hydroxyl group is present. This is our benzoin we get after this step. So this is our product after first step. Now what they give? Dilute HNO3, oxidize this carbon, and here carbonyl group is formed. In second step they give dilute HNO3. So dilute HNO3, oxidize this carbon, and here one carbonyl is formed. So after react with dilute HNO3, this carbon oxidize, and what we get? We get 1,2-dicarbonyl group. What we get? We get 1,2-dicarbonyl group. Like here also one carbonyl. So here what we get? 1,2-dicarbonyl group. So here we get 1,2-dicarbonyl. So here second name reaction came, benzyl benzylic acid rearrangement. In benzyl benzylic acid rearrangement, 1,2-dicarbonyl we get after this step. So this 1,2-dicarbonyl convert into benzylic acid. So how it happen in our reaction? Let's do. So in the presence of aqueous KOH, It is our basic medium. This is our first step. This is our second step. And this is our third step. In third step, here they give aqueous KOH. In KOH, this OH group act as nucleophile and attack on one carbonyl group. So here he attack here or attack here. Both are same condition. So this hydroxide or nucleophile attack on C1 carbonyl group or C2 carbonyl group. So we choose this path. Both are same. After the attack by this hydroxyl group, this carbon oxygen bond will open and this bond electron shift to this oxygen atom. So here what we get, here all rings are remain same. At this carbon, one hydroxyl group attach. On C1 carbon, this carbon oxygen bond will open and one hydroxyl group attach with this carbon. So here this hydroxyl group attach here and this is our O negative and C2 carbon and C2 carbonyl group same. So after this step, this oxygen electron return again here. This oxygen electron return to this carbon oxygen bond and this bond will be break and this bond will be break and new carbon carbon bond is formed here. So this bond will break and new carbon carbon bond form here and this electron shift to this oxygen atom. So what we get here, ring contraction happen. Ring contraction happen here. So after ring contraction, what we get, 1 2 3 4 5 6. So here new bond is formed between C6 and C2 carbon. New bond is formed between C2 and C6 carbon. 6 5 4 3 2. So after ring contraction, 6-membered ring convert into 5-membered ring and here what we get, C1 carbon, we get 1 C double bond O and 1 and C1 carbon convert into acid and this C1 after ring contraction, so here new bond is formed between C6 and C2 carbon and C1 carbon convert into acid and here C2 carbon 1 O negative is present. This product after ring contraction in the presence of H2O, after acid base reaction or react with H2O, our product look like this. Here one 5-membered ring is formed. Here we get 6-membered ring and here we have one hydroxyl group and in this carbon we have one carboxylic acid. So this is our final product. Let's check in given options. If you check option, you can easily eliminate option number C and option number D. Why? Because here they give 6-membered ring between two phenyl rings. Between two phenyl rings, they give 6-membered ring. 5-membered ring in our product. So you can eliminate these two options very easily. Now check between A and B. So here you saw in option B, here 5-membered ring is present but one hydroxyl group is absent. So you can eliminate this option also. Now you check option A, here hydroxyl group is present and one carboxylic group is present, and this is 5-membered ring between two phenyl ring. So this is the correct option, and option A is correct for given reaction. So here two name reaction involved in this question. So whenever you go for examination, always learn name reaction and make this kind of notes, so you can easily recall name reaction in your examination hall. You learn these kind of name reaction with tricks, and this will every time help in your examination. Thank you all. If you like my video, do like, share and subscribe. Thank you.